All right, so today we're diving deep into a system that's making some real waves in the world of formal theorem proving.
Oh, wow.
It's called LeanAgent, and it's not just solving math problems, it's actually discovering brand new proofs.
Yeah, that's right.
Even in super complex fields like abstract algebra and topology, we're talking potential paradigm shift here, folks.
Yeah, definitely a fascinating development. The research paper LeanAgent, Lifelong Learning for Formal Theorem Proving, it lays out this vision for AI that goes way beyond just fixed data sets.
Right, like it embraces this dynamic, ever-evolving nature of math.
Exactly.
And that paper is our main source for today's deep dive.
Absolutely.
It's published just last week on ArtsGive by researchers from Caltech and Stanford, and it's making a lot of noise in the AI community.
Oh yeah, it's a hot topic for sure. The paper really dives into a big limitation of existing theorem provers.
Oh yeah, what's that?
They struggle to generalize to new mathematical domains.
Oh.
You know, the authors, they actually say existing neural theorem provers are typically trained on a fixed data set of theorems from a single mathematical domain. This limits their ability to generalize to new domains, which is a crucial requirement for lifelong learning.
So it's like training a chess AI on only one type of opening.
Right.
It might get really good at that specific opening, but then when it faces a new strategy,
It's going to struggle.
yeah, it's going to
Yeah.
fall apart.
Hmm.
So that's where LeanAgent comes in with its super novel approach to lifelong learning
Yeah.
in theorem proving.
Right.
And the paper highlights these three key components:
Mm-hmm.
curriculum learning, a dynamic database, and progressive training.
Right.
So let's unpack those one by one.
Okay.
Starting with curriculum learning, how does LeanAgent avoid getting totally overwhelmed
Yeah.
by all of this vast mathematical knowledge out there?
So think of it like a carefully designed syllabus.
Yeah.
You know, instead of throwing LeanAgent into the deep end with super complex theorems right off the bat,
Right.
it starts with those simpler concepts and then gradually increases the difficulty. The paper explains how LeanAgent uses this metric to rank mathematical repositories by difficulty.
Okay.
And they say, to measure the complexity of a repository, we use ES, where S is the number of steps in the proof.
So the more steps in a proof,
The more complex it is.
the harder it is.
Yeah.
Makes sense. But how does LeanAgent actually decide which repositories to tackle first?
So it starts with the repositories that have a high number of those easier theorems,
Right.
focusing on those in the 33rd and 67th percentile of complexity.
Oh, okay.
And this approach allows LeanAgent to build a really solid foundation
Yeah.
before moving on to those more challenging domains.
So starting with arithmetic before you move on to calculus
Yeah.
and then abstract algebra.
Yes, exactly.
Okay, cool. And this gradual progression is crucial for preventing catastrophic forgetting,
Yes.
right? Which is that tendency for AI to forget
Right.
stuff it previously learned when it sees new data.
That's right. By starting with the simpler concepts and gradually increasing complexity, LeanAgent doesn't overwrite its existing knowledge base. It builds upon it in a more structured way.
Okay, so we've got curriculum learning down.
Mm-hmm.
What about this dynamic database?
Okay.
What role does that play in this whole setup?
So LeanAgent's dynamic database, it acts like its long-term memory.
Okay,
It stores all the theorems and proofs that it encounters, right?
gotcha.
Along with crucial details about dependencies and the tactics used to prove them.
Okay.
The paper describes it as an evolving mathematical library that is used to generate data sets for progressive training.
So it's not just memorizing proofs, it's actually building a deep and interconnected understanding of these mathematical concepts.
That's exactly right. And this evolving knowledge base, that's key to LeanAgent's ability to not only prove existing theorems, but to actually discover new ones.
Wow, that brings us to the results, which are pretty mind-blowing.
Oh, yeah.
The paper says that LeanAgent has already proven 162 theorems that were previously unsolved
Wow.
by humans
That's a lot.
across 23 different Lean repositories. So it's not just proving what we already know, it's contributing to math
Yeah.
in a very real way.
Absolutely. It's pushing the boundaries of what we know.
That's incredible.
Yeah.
Now, for our listeners who are deep in AI engineering and research, can we look at some specific examples of what LeanAgent has done? I'm really interested in how it tackles these different math domains.
Sure, let's do it. One really cool example is its success in the polynomial Freiman-Riese repository, PFR for short.
Okay.
And this repository deals with cutting-edge mathematical research. LeanAgent was able to prove the Kohn-Roof translate theorem with crazy efficiency.
Wow.
And here's a snippet of the proof
Easy.
theorem. Condor translate SFE, SFRE, hum FG, ASET G, SET, Condra SS, SX, Condro AS begin, Condro SX, Condro ASX, Condro AX, Condro ASX, LASX, Condro ASX, Condro ASX, Condro AX, Condro XXXX, and XX is all NEX to me.
I'll be honest, that looks like a foreign language to me.
Yeah, it's pretty dense.
But for our AI engineers and researchers who are fluent in LeanAgent, I'm sure that's super impressive. What's so special about this proof?
So what's really cool is that LeanAgent found this concise and elegant proof
Okay.
for a theorem that involves some pretty complex mathematical concepts. It shows its ability to grasp and apply knowledge from like the forefront of research.
So it's not just brute forcing.
Right.
It's way through, it's showing like real understanding and insight.
Exactly. It's demonstrating an impressive level of mathematical understanding.
That's remarkable.
Yeah.
And we see this even more in its performance in the Selenium repository,
Right.
which focuses on scientific computing.
Mm-hmm.
LeanAgent here, it shows off its progressive learning capabilities
Yeah.
by starting with basic theorems about algebraic structures.
Mm-hmm.
And then it goes on to prove theorems involving sophisticated bijections.
Right. Those one-to-one correspondences between elements of different sets.
Exactly. So it's climbing the mathematical ladder step by step.
Yeah, like conquering one level and then moving on to the next.
Mastering these concepts and applying them to more and more complex problems.
Exactly. And the paper actually highlights this progression.
Okay.
They state that LeanAgent was able to prove increasingly complex theorems in the Selenium repository. It started by proving basic theorems about algebraic structures and then advanced to proving theorems involving sophisticated bijections.
Okay.
And here is a snippet from one of those complex proofs, specifically Selenium.conc map f data, Lean theorem, conc map f data, say f.enumber, f.edf data, f.edf f begin, f.eda, 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 f.edf data. Conc map f data, continuous linear map.5nk, f.eda, f.cnn, pi.apply 0, f.eda, fn.
Again, not really my area of expertise,
Yeah.
but the fact that LeanAgent is tackling these complex theorems in a domain like scientific computing is pretty significant, right?
Yeah, it really is, because it suggests that LeanAgent's capabilities, they could impact not just pure mathematics, but also fields where formal verification is like super crucial, like software development and engineering.
That's fascinating. Now, I know LeanAgent has proven theorems across a variety of mathematical domains, but are there any areas where it seemed to particularly excel or struggle?
So interestingly, LeanAgent showed a real knack for abstract algebra.
Oh, okay.
This was clear from its proof of Wedderburn's little theorem in the formal book repository.
Okay.
This theorem is a cornerstone of abstract algebra, and LeanAgent managed to find a remarkably short proof, just one line of code.
Wait a minute, a one-line proof for a theorem that's like a fundamental concept in abstract algebra?
No, right?
That's got to be a record.
It pretty much is,
Yeah.
especially when you compare it to the human-written proof, which spans 175 lines.
Oh, wow.
Here's that one-line wonder, Lean. Theorem Wedderburn R-type. Ring R, finite R, no zero divisors R, ice field R, theorem Wedderburn R by exact field dot to ice field.
Wow. So LeanAgent is not just finding proofs, it's finding like really elegant and efficient proofs.
Yeah, it's really impressive.
That's incredible.
Yeah.
Can you break down what's happening in that proof for those of us who aren't abstract algebra experts?
So essentially, LeanAgent is using this powerful premise in Lean called field.toys field.
Okay.
This premise states that if you can show that a ring has no zero divisors, meaning you can't multiply two non-zero elements and get zero,
Right.
then that ring is also a field.
Gotcha.
So LeanAgent, it recognized that the conditions for Wedderburn's little theorem already satisfied this field.toys field premise, and it just applied it. It's like it connected the dots and used its knowledge base in a really sophisticated way.
This is all so exciting. It seems like LeanAgent is really pushing the boundaries of what we thought was possible with AI and math.
Yeah.
But before we get too carried away, I think we need to talk about the potential downsides. What about the risk of AI exploiting loopholes or finding these proofs that aren't actually valid?
That's a really important point, and the researchers actually acknowledged this in the paper.
Oh,
They actually included some trap theorems in their evaluation theorems that were designed to be unprovable.
oh, interesting.
These traps were basically placeholders with 0-1 statements,
Right.
which are mathematically impossible.
Of course, right. So what happened? Did LeanAgent fall for the traps?
Well, in a way, yes, LeanAgent did prove some of these trap theorems.
Oh, no.
And this highlights the potential for AI systems to exploit loopholes or find proofs that aren't actually valid.
Okay, so that's a little concerning. So does that mean we can't trust AI-generated proofs at all?
Well, Well, it's not really about trust. It's more about recognizing that AI systems are still under development,
Right.
and we need to be aware of their limitations. The researchers emphasize that these findings underscore the importance of rigorous testing and benchmark design in AI research.
So we need to develop ways to evaluate these proofs
Yeah.
and be able to tell the difference between genuine mathematical insight and just like a clever exploitation of a loophole.
Exactly. We
Mm.
need evaluation frameworks that can tell the difference.
Okay, so how do we measure LeanAgent's performance in a way that accounts for all these nuances? Like, how do we know it's really learning and not just finding shortcuts or exploiting loopholes?
That's where the concept of lifelong learning metrics comes in.
Okay.
The paper details 7 specific metrics
Okay.
that they use to evaluate LeanAgent's performance.
Mhm.
These metrics, they go beyond simply counting the number of theorems proven.
Yeah.
They give us a more nuanced assessment of its learning capabilities.
Okay, so we're looking at the quality of its learning journey, not just a pass or fail.
Exactly. We want to understand how it's learning, not just what it's learning.
Can you give us an idea of what these metrics are and what they tell us about LeanAgent's abilities?
Absolutely. So the researchers grouped these metrics into 2 main categories. Stability, which measures how well LeanAgent remembers what it's learned,
Okay.
and plasticity, which assesses its ability to adapt and learn new information.
So it's about that balance between remembering the old
Yeah,
and embracing the new. Sounds like a good skill for any learner.
right. Whether it's human or AI.
Exactly. And LeanAgent is scored really well on both.
Yes.
It showed its ability to learn continuously without forgetting what it already knew.
Yeah, it's a really promising sign.
That's impressive.
Yeah.
Let's dive into those metrics a bit more. Starting with stability, what specific metrics did they use to assess its ability to retain knowledge?
Okay, so they used 3 key metrics. Windowed forgetting 5, which is WF5.
Okay.
Forgetting measure, which is FM.
Okay.
And catastrophic forgetting resilience, or CFR.
Got it.
WF5 measures how much LeanAgent forgets over a 5-task window.
So it's like checking in every 5 lessons
Right.
to see what it remembered.
Exactly. And a lower score is better here, meaning it's holding on to that knowledge.
Okay. Makes sense. What about the forgetting measure?
So FM calculates the average performance drop on old tasks.
Right.
After learning new ones, again, a lower score is better indicating greater stability and less forgetting.
So it's a measure of how well it can hold onto that knowledge even when it's learning new stuff.
Yeah, it's like how well it can juggle multiple concepts without dropping the ball.
Got it. Okay, what about catastrophic forgetting resilience? That sounds intense.
It is a crucial metric, especially in lifelong learning. So CFR looks at the ratio between LeanAgent's minimum and maximum average test performance.
Okay.
A higher score here means it's more resistant to that sudden drop in performance that we call catastrophic forgetting.
So how well it handles that influx of new information.
Exactly. Does it adapt or does it crumble under pressure?
And what were the results?
The results were promising. LeanAgent got impressive scores on all 3 stability metrics,
Oh, wow.
showing it can retain knowledge really effectively even as it continues to learn.
That's encouraging.
Yeah.
So it suggests that its approach to lifelong learning is actually working.
Yeah, it's a good sign.
But we still need to look at the plasticity side.
Right.
Right. How well does it adapt to new information and incorporate that into its existing knowledge base?
That's a great question, and that leads us perfectly into the next part of our deep dive.
All right, so stay tuned, everyone. We'll be back in just a moment to continue exploring LeanAgent and its remarkable ability to learn and grow.
So welcome back to our deep dive into LeanAgent. Before the break, we were talking about how LeanAgent is really good at remembering what it's learned.
Right, like even as it's learning new things.
Exactly.
Yeah.
Which is key for a good lifelong learner.
Yeah, whether it's AI or human.
Exactly. But a good learner isn't just good at remembering.
Right.
It's also adaptable.
Yeah.
It can integrate new information and change its understanding.
It's like that saying, it's not what you know, it's how you learn.
That's a good one.
That really matters.
Mhm.
And in AI, that adaptability is called plasticity.
Yeah, that's right.
Yeah.
So how did the researchers measure LeanAgent's plasticity?
Yeah. How'd you do that?
Well, they used 3 metrics to see how well LeanAgent adapts to new information.
Okay.
Expanded backward transfer, EBWT,
Okay.
windowed plasticity 5, or WP5,
Gotcha.
and incremental plasticity, IP.
Okay, so 3 different ways to look at it.
Exactly. And let's start with EBWT because it's a really interesting concept.
Okay.
It measures the average improvement on old tasks after learning new ones.
Wait, so learning new things can actually make LeanAgent better at old things?
Yeah, it sounds counterintuitive, but
Okay.
think about it like this.
Wait.
Let's say you're learning to play a new musical instrument.
Okay.
As you master new techniques and musical concepts,
Yeah.
you might find that you've also improved your understanding of an instrument you learned before.
Oh, interesting.
The new knowledge creates these connections and insights that make you a better musician overall.
So you're building on what you already know.
Exactly.
Okay, so I can see how that applies to LeanAgent.
Right.
By learning new mathematical concepts and proof techniques, it can actually refine its understanding of things it's seen before.
Exactly.
Maybe even finding more elegant or efficient solutions.
That's exactly what EBWT measures.
Oh, cool.
A higher EBWT score means that LeanAgent isn't just learning new things in isolation. It's integrating that knowledge into what it already knows.
It's all connected.
Yeah, it's building a more complete understanding of math.
That's remarkable. So it's like LeanAgent is constantly getting smarter and more insightful
You got it.
with each new theorem it tackles. What about those other plasticity metrics, WP5 and IP?
Right, so WP5, windowed plasticity 5, is the opposite of the forgetting metric we talked about earlier, WF5.
Oh, okay.
It measures the maximum performance increase over a 5-task window.
Okay, so it's like a learning agility score.
Yeah, exactly. How quickly it can pick up new concepts and apply them.
So how flexible and adaptable it is when faced with new challenges.
Precisely. And then there's IP incremental plasticity.
Okay.
This gives us an even closer look at plasticity than WP5.
Okay.
It tracks the rate of performance change for each new task.
So it's like measuring its learning speed.
Exactly. How fast it can absorb new knowledge.
Okay. And did it do well with those metrics?
Oh yeah, just like with the stability metrics, LeanAgent did exceptionally well in the plasticity department. It showed that it can quickly adapt to new information and use it effectively. The paper states that LeanAgent achieves exceptional scores in stability and backward transfer, meaning that it can retain previously learned knowledge while also using new knowledge to improve its performance on older tasks.
That's incredible. So it's finding that balance between stability and plasticity,
Right.
remembering the past and embracing the future.
It's a delicate balance.
Yeah. But with all these metrics, 7 in total,
Yeah.
it's kind of hard to get a big picture view of how well it's doing overall.
You're right. That's why the researchers created a composite score,
Okay.
which combines all 6 of those previous metrics into one single score.
So it's like a final grade,
Yeah, exactly.
showing the overall balance between stability, improvement, and plasticity.
Right. And the results are pretty amazing.
Okay, what is it?
LeanAgent got a near-perfect composite score of 94%,
Wow.
which highlights its exceptional ability to learn and adapt continuously.
That's incredible.
The paper says that this composite score reflects the overall balance between stability improvement and plasticity, demonstrating LeanAgent's ability to learn effectively over time.
So it sounds like LeanAgent is really crushing it.
It is.
But no system is perfect, right?
Yeah.
Are there any limitations or areas where it could be improved?
Of course. The researchers themselves point out some limitations.
Like what?
Well, for example, they say that LeanAgent can struggle to prove some theorems,
Oh, why is that?
because the training data might not have enough examples in those specific math areas.
So it's like trying to teach someone a new language,
Right.
but only giving them a few words and grammar rules.
Exactly. They might be able to form simple sentences,
Right.
but they'll struggle with more complex ideas.
Okay, so it needs more data.
Right. The researchers actually say in the paper, LeanAgent has limitations in proving certain theorems due to limited data in specific topics, suggesting potential for future research.
So the quality and breadth of that training data is super important.
It's-
for developing these powerful and versatile AI systems.
Absolutely. And the researchers suggest that future work could focus on developing more resource-efficient methods for lifelong learning in theorem proving.
Okay.
One interesting avenue they propose is using reinforcement learning techniques for synthetic data generation during curriculum construction.
So instead of just relying on existing math repositories, we could train these AI systems on artificially generated data.
Yeah.
That could really expand their knowledge base.
It could, and potentially overcome some of these limitations.
That's a really fascinating area of research.
It is.
I'm curious to see how that develops.
Yeah.
But before we get too far into the future of AI and math, I want to go back to something we talked about earlier.
Okay, what's that?
LeanAgent's ability to exploit loopholes and prove those theorems that were intentionally designed to be unprovable.
Right, the trap theorems.
Yeah, that's a really important point.
Yeah.
It brings up some big questions about how we evaluate and interpret these AI-generated proofs. The fact that LeanAgent proved those trap theorems shows that AI could find clever solutions that might not actually be mathematically sound.
Yeah, it's a good reminder that we can't blindly trust AI no matter how impressive it seems.
Right. We can't just take it at face value.
Exactly. We need solid ways to evaluate these proofs, and we need to think critically.
Yeah. So we're not being tricked by some clever AI tricks.
We need to find that balance between embracing AI's potential and being a little skeptical.
Right.
These AI systems like LeanAgent, they're powerful tools,
Yeah.
but they're still just tools.
Right.
It's up to us, the humans, to make sure their output makes sense mathematically.
So we can't just hand over all responsibility to the AI.
No, we need to stay involved and make sure things are on the right track.
That makes a lot of sense.
Oh, yes.
So that brings us to a bigger conversation.
What's that?
The role of AI in math and the future of scientific discovery.
Yeah, that's a big one.
Okay, so let's dive into that. We'll be right back to explore the impact of LeanAgent and other AI systems on how we approach mathematical research. And we'll have some thought-provoking questions for our listeners to think about. Don't go away.
Welcome back. So as we've been exploring LeanAgent's capabilities, its performance on those lifelong learning metrics, and even its limitations,
Yeah.
I'm really struck by what AI is achieving in math. It feels like we're seeing this whole new era of scientific discovery unfold.
I totally agree.
Yeah.
And throughout this episode, I keep thinking about how LeanAgent isn't just like solving math problems.
Right.
It's like challenging our ideas about learning itself.
Oh, yeah.
Its success with curriculum learning, gradually increasing the difficulty of the theorems.
Right.
It's just that maybe we could learn something from this AI.
It makes you wonder if our human approaches to education, often based on memorization and separating knowledge into different subjects,
Right.
if they could be improved by taking inspiration from LeanAgent.
Yeah. What if we encourage students to explore these interconnected fields and gradually build their understanding by emphasizing the links between different subjects?
It's a really fascinating idea.
Yeah. A world where education mirrors the way knowledge actually works.
Yeah,
All connected and organic. And AI could play a big part in making that happen.
absolutely. Imagine AI systems like LeanAgent acting as personalized tutors,
Yeah.
guiding students through these tailored learning journeys.
Yeah.
They could create custom challenges, offer insights that link different areas of study,
Mm-hmm.
and adapt to each student's pace and learning style.
So it's like a personalized syllabus and a dedicated mentor all in one.
Exactly.
That could be revolutionary for lifelong learning.
It could really nurture curiosity
Yeah.
and help students become active learners.
Exactly. But as we think about this future where AI and education are intertwined,
Yeah.
we have to remember that human intuition and creativity are still super important.
Absolutely. Even the most advanced AI can't replicate those aha moments, those flashes of insight that lead to those big discoveries.
Yeah. Right. AI is amazing at processing data and finding patterns that we might miss.
Yeah, it can be this powerful ally in research,
Yeah.
helping us analyze information and explore new ideas. But that uniquely human spark of creativity, that ability to connect seemingly unrelated ideas in new ways,
Right.
that's still essential for those true breakthroughs.
So it's not about AI replacing human researchers.
Right.
It's about collaboration.
Yeah. Oh,
Using the strengths of both AI can handle the heavy lifting,
Mm.
the data, processing the pattern analysis,
Mm-hmm.
and humans bring the intuition, the creative leaps, and the critical thinking to guide research in the right direction.
I picture this future where mathematicians and computer scientists work side by side with AI systems,
Yeah.
each contributing their unique strengths to the pursuit of knowledge. It's a vision of collaborative discovery where AI amplifies human ingenuity.
I love that.
Yeah.
And as with any powerful technology, there are ethical questions we need to consider.
Oh, definitely.
For example, if AI becomes really good at generating mathematical proofs, how do we figure out authorship or intellectual property?
Right. These are totally new challenges that we need to think about carefully.
It's uncharted territory, and we need to navigate it thoughtfully as a society.
AI is forcing us to rethink our ideas about recognizing contributions and giving credit. We need new models that acknowledge the roles of both humans and AI in research.
It's a challenge that requires us to think deeply and have conversations across different fields.
Definitely. Philosophers, ethicists, legal experts, AI researchers, we
Mhm.
all need to work together to make sure these advancements benefit everyone while respecting ethical boundaries.
Absolutely. So this leads us to our final thought for our listeners, something to consider as they continue their own work in AI.
Okay.
We've talked about LeanAgent's ability to prove existing mathematical conjectures.
Right.
But what about generating new ones?
Now that's interesting.
Could AI help us identify promising areas of mathematical exploration?
Yeah.
pointing us towards questions we haven't even thought of yet.
That's a really exciting possibility. As AI gets more sophisticated, I think it will be able to not just solve problems, but also to help us ask new questions,
Yeah.
suggest new research directions, even spark whole new fields of mathematical inquiry.
It's a vision of AI as this catalyst for mathematical innovation,
Exactly.
accelerating discovery and opening up new avenues of understanding.
It's a future full of possibilities.
And that brings us to the end of our deep dive into LeanAgent. We've gone through the intricacies of lifelong learning, looked at AI-generated proofs, and considered the potential of AI to transform mathematics.
It's been a great discussion, and I hope our listeners, especially those working in AI, will keep thinking about these ideas, grappling with the challenges, and helping to shape a future where AI helps us reach new levels of understanding.
Absolutely. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible. And remember, the pursuit of knowledge is a journey best undertaken together, humans and AI side by side.